Suppose that we've got two random variables x and w, and we combine them by multiplying x by a constant a and w by a constant b to construct a new random variable y, and we want to find the variance of y. So how are we going to do this? Later on in the problem, it's going to be important to know the formulae for the variance and the covariance between two variables. The variance of a random variable x is just defined as the expectation of that random variable x squared minus the square of the expectation of x, and the covariance is equal to the expectation of x multiplied by w minus the product of the expectations. So we want to try and find the variance of y, where y is equal to ax plus bw. So we're going to use our first formula here to find the variance of y. So the variance of y is just the same as the expectation of y squared minus the expectation of y all squared. Now, in order to analyse this further, we're going to need to substitute in the x and w variables in place of the y's. So we can rewrite this as being equal to the expectation of y squared, but y is just equal to ax plus bw. We square that, minus the expectation of y. And remember, y is just equal to ax plus bw. And that whole expectation is going to be squared. So how are we going to evaluate this? Well, the first thing to note is we know how to expand out a square. So we know that ax plus bw squared is the same as a squared times by x squared. We're squaring the first term, plus we square the second term, b squared w squared, and then we've got two lots of the cross product terms, so ab times by x w. And before, remember, this was all in an expectation, so we still have to take the expectation term in there. So we've got the expectation of a squared x squared plus b squared w squared plus 2ab times by xw. We also have this second term, the expectation of ax plus bw, which we're going to square. Now, we're going to use one of our rules of expectations, and we know that the expectation of a sum is the same as the sum of the expectation. So we can split this expectation up into two separate parts. So we're going to be looking at the expectation of ax plus the expectation of bw. And all of that will end up being squared. Now, a is a constant and b is a constant, so those can be taken outside of the expectation, leaving us with the following. So let's try and move a little bit further in our analysis. We know that on this first term, we've got the expectation of three things added together. A, b, and ab are all constants, so we're going to take the expectation of a sum, which is the same as the sum of the expectations, and we can take the common multipliers outside of the expectation. So this is going to be equal to a squared times by the expectation of x squared plus b squared times by the expectation of w squared plus 2ab times by the expectation of xw. So that's this first term, and the second term we've got minus, we're going to square this bracket. So we're going to have minus, squaring the first term, we'll have a squared times by the expectation of x all squared. So that's a squared times by the expectation of x all squared. Then we've also got b times by the expectation of w, which we squared, giving us plus b squared times by the expectation of w all squared. And then we've also got two lots of the cross product terms, giving us 2ab times by the expectation of x times by the expectation of w. Now let's group the terms together, and what we'll end up with is that we have a squared times by the expectation of x squared minus a squared times by the expectation of x all squared. We've got a common multiplier of a squared, so let's take that out the front. So that's a squared times by the expectation of x squared minus the expectation of x all squared. Then we've also got b squared times by the expectation of w squared minus b squared times by the expectation of w all squared. So again, we can take the common multiplier of b squared outside. So that's b squared times by the expectation of w squared minus the expectation of w all squared. And finally, we've got 2ab, that's a common multiplier, times by the expectation of xw minus the expectation of x times by the expectation of w. So that's plus 2ab times by the expectation of xw minus the expectation of x times by the expectation of w. But from our definitions above, we know that this is just equal to the variance of x. Similarly, the expectation of w squared minus the expectation of w all squared, that's just going to be equal to the variance of w. And the expectation of xw minus the expectation of x times by the expectation of w, that is just by definition equal to the covariance between x and w. So we can rewrite the variance of y as just being equal to a squared times by the variance of x plus b squared times by the variance of w plus 2ab times by the covariance between x and w.